So in week 10, we're going to cover conditional statements, and conditional statements really come down to one thing, which is really a couple of functions, but the main kind of driver is a case statement. And so, I'm not going to necessarily go over 100% again what a case statement is necessarily, because we're going to kind of cover it in bulk here. But I just wanted to kind of basically what I thought we could do is we could start off by covering question 4 of the exercise, and then kind of go from there, because this is actually a really good example of kind of how to do it. And then after we do that, I'll show you a couple of really cool things you can do when we kind of mesh case statements with aggregations, which is really cool. You can build some really cool reports. I kind of touched on it in the announcement, but I think it's worth going over. So anyways, feel free to stop me if you have any questions or if I'm going too fast, but I'm just going to kind of just dive right in. So basically the goal behind question 4 is we want all the letters of the alphabet. And we want that, basically we want a count of 2 different categories. And it says in the book, which I'm pulling it up here, chapter 11. Always have to look it up. So what makes someone inactive or active? Defined in textbook examples. So let's look here where we go to our active, inactive. And I've missed it somewhere. I was pulling this up and then got busy. Okay, so here it is. So active versus inactive. To indicate if query results, blah, blah, blah. Let's see what it. And of course, oh, got it. Okay, let's see if, let me just make sure we have this column before I. And let's see, tequila. Right, so there's our active, inactive column, which I wish I would just say that in the instructions because it shouldn't be that difficult. But anyways, active, inactive. So basically what we're going to do is we want all of the last names. And, we've kind of done this before where we've said, so let's select, the substring of last name. Last first letter from customer. We've done things like this where we've gotten, kind of like our list with a count, which is kind of like what we're going to do here. But what we're going to do a little different is, and I'll show you, is the problem why we can't just kind of like go this route is because we don't have every letter of the alphabet, and that's what we want. So if I were to do as people, we just need a group by last first letter. There we go. So this is kind of like our starting point, so to speak. So you can see here the count of all of our people with each letter of the alphabet. The problem is, like I said, we're missing some of the alphabet. So step 1 of question 4 is we want to first use what we learned a couple weeks ago when we did set theory to build the letter of the alphabet. So what I do is I start by having all of the letters of the alphabet, and this is where text editors can help a lot. So I have every letter of the alphabet, and what I'm going to do is I'm actually going to just get I'm just going to use find and replace to like my advantage here. So let's start out by finding all of our carriage returns. And I'm going to replace that because it's on the other side. What I'm going to replace it with is another carriage return. And well, actually, let's do this. I'm going to replace it with union. Actually, let's do carriage return, union all, carriage return, and then select space quote. And actually, let's cheat just a little bit more. We're going to do that as letter. So let's see how we do here. There we go. So then all we have to do is fix this and say select. And there we go. We should have all of our letters. We just need to kind of polish that off. So now if I take this and we were to put it over here, I should be able to select this and I get a table with all the letters of the alphabet. So now that we kind of have that, what we can do is what we want to start by just kind of getting all of our customers and joining it to this table. So similar to before, we're going to take and select, but in this time we're going to select our, and I'm going to just call it alph.letter for alphabet. And then we want to select the count of customer ID as customer count. And we'll select that from, and this is kind of where we get to use our little query here. So in this case, we're going to grab this, put it in here, tab it over. And I'm going to use this to my advantage here because it just makes it a little easier. Well, so that will get us our letter. And we're going to call this table alph for alphabet. And then from that, we are going to left join customer, call it C. And we're going to do this based on the first letter of the customer. So if we go back up to our first little example, so we're going to say on alph.letter is equal to the substring of last name. And if we want to be just extra precautious, we could technically, upper this or whatever. If you wanted to do a lowercase, either way works. The safest bet would be to upper both, but I'm not going to worry about it since we know that they're actually, you know what, I am going to worry about it. Just as a fail safe. I know that all mine are uppercase. We'll just make sure. All right. And then if we group by alph.letter, we should get kind of our same result set. And I just need to spell correctly. And then it should work. So now we get all the same results. You'll just notice that this time these are 0 because we don't have any customers with that. So this is kind of like our total customers column. So I'm actually going to call this total count because we're going to add a couple more things. So if we go back and look at our example, what we really want is we want the count of active and the count of inactive to kind of add up to this total. And so the way we kind of do that is we're going to use this customer.active column. So inside the customer table, there's an active column, and we're going to use that to kind of base our counts on. But how we do that can be a little tricky. So this is where we get to use aggregation mixed with our case statement to do some really cool stuff. So just like before, we're going to do a count of customer ID. The only difference is like we said, we kind of want this logic in there. So inside of our count, instead of just saying customer ID, we're going to say case. And I'm going to say when customer ID, or when C dot active is equal to 1, then customer ID, C dot customer ID, end. So basically the way a case statement works is we say case when, and then we put some condition like 1 equals 1, then, correct, else false, and then we finish it off with end. So this is kind of our basic kind of case statement, and we can do logic here however we want. Whatever goes here, we can kind of do on the fly. You can also nest case statements if you want to. So there's some little background. So basically what we're saying here is when C.active is equal to 1, then we're going to return the customer ID. So this is evaluated on a row by row basis. So if I were just to select everything from customer, basically it's going to go through here, and like Mary Smith is going to basically have another column called customer ID. So in this case, 1, and it's going to do that for all the ones that are active. When it hits one that's not active, since we don't have anything else in here, it is just going to be blank. So it'll be null. And then once that finishes, we're going to take the total count of that. So we're going to just add up all the distinct customer IDs, or just count all the customer ID values, which in this case is going to be whatever kind of we have here. So let's name this as active count. And let's go ahead and run this. There we go. So here is our kind of our numbers. We can see who's active out of those. And so now we just need to do this again for our inactive count. The only thing is we want to change this because we only want to count customer ID where C.active is equal to 0. And we'll call that inactive count. And there we go. And you'll notice that if we've done everything right, our active plus inactive count should add up to our total. And I know the exercise doesn't necessarily have the total, but yeah, it's all there. And like someone brought up earlier, I think it was Scott said that the count is a little off for the A letter, and it looks like that's true. So in the instructions, it has 18 and 2 for the active and inactive, when it looks like for whatever reason it's really 19 and 1. Maybe someone changed something somewhere in the instructions, so we can get that fixed. But anyways, that is exercise 4. Does anyone have any questions on that? All right. Now what I'll do, just because I think it's helpful to kind of understand what's going on without the aggregation, I'm actually just going to take it right out. So instead of counting all these, I am actually just going to pull the raw information here. Because really, whenever we're doing aggregation, if you ever want to kind of, I guess, see what's going on underneath the hood, you just take the aggregation off, because the aggregation basically just happens at the end. So in this case, we can kind of see like the customer ID, the first letter, and their active status. So let's say C.active. All right. So here is all of our customers, and by the letter of their name. And you can see here basically what's happening with our case statement. So with our case statement, this is our active case statement, then our inactive. You can see the ones where they're active, it just puts their customer ID here, and the ones where it's inactive, it leaves blank. So really you can kind of go through here, and basically when it goes to do the count, it just counts all the non-null ones. So in this case, we end up with our total active and our total inactive counts. And so that's what's really cool about those case statements, especially in aggregation, is you can kind of subset your data. It's almost like a pivot table in Excel. you can kind of take like an aggregation and add it as a column versus, you can kind of subset your data and add as columns. So any questions on that? Anything you guys want to see with this one in particular? Okay. And just to polish this off, let's just do question 5 since we're here. So question 5 really is just question 4 with one append. So we have the count of our customers who are active, and it wants to find only the letters where the count of active customers is greater than 30. So basically we can just take really this active count, and this is how easy this is. We can just say having an active count greater than 30. And there we go. 8 records. Let's just make sure. Yep, 8. So it looks like we're good there. So basically it's just one little clause, and that's really part of the group by, which is we just add this having. And one of the nice things about MySQL that isn't available in like Postgres is the fact that we can use this nice little, we can use the alias in the having and technically the group by, but we can use this alias in the having clause, which makes it really, really fast and easy. Otherwise, you could just actually just take and copy that and just put it right down there, and same thing. So any questions on that little change? All right. Okay, so just a couple more examples on that, because I think it's honestly, it's really it's a staple practice of writing reports, which, in the database world, it's most of the time, I would say that, there's a very small percentage of people that go into the database field that get to, really, let's put it this way, the large percentage of people who go into the database field are writing reports, not necessarily, designing the systems themselves. Just because it only takes a couple people to design a system, but it takes many people to kind of use it. So writing reports is huge, and this kind of practice is really, really helpful. So as an example, if we kind of wanted to kind of see a breakdown of some different information, like with our payments. So if I select everything from payment, in here we have the payment date, and I think we've done this before, where basically, you can see we have payment date, and I think we've done it before where we say, oh, I want to know the year of payment date as fiscal year, the month of payment date, and let's use month name. Fiscal month, and then if we wanted to take the sum of amount as total revenue from payment, then we just need to group by fiscal year and fiscal month. So we've done this before, where basically we took all of our years and our months and we kind of have a total revenue. But what if we kind of wanted to see this like in like a pivot view, where maybe we want to see kind of like more year over year, because this is a very vertical kind of view. And let's say that we kind of want to raw get out some different information. Like maybe we want to keep the year as our row, but maybe we want the month as our column. So this is where we get to have some fun. So we say some case when the month of payment date is equal to 1, then January. or whoops, then amount. End is January. So now basically what we're doing is we're saying, oh, if the payment date is in January, then return the amount, and we're going to sum that. So now if we were to run this up, and we need to take this out. And there we go. So we don't have anything in January. So what we're going to do is we're going to just do something here where we say else, then amount, else 0. So basically, I'm just going to add that else clause so that way we don't see nulls there. We'll just see 0, especially when we're kind of doing these sums. So now what we can do is we can just take and replicate this for each month. April, May. Maybe I should have done quarters. Maybe we'll do quarters next. Let's just stop there for right now. So now you can see we're kind of putting our results like over top of each other. So that way, you know, if our data was a little bit better, I'm actually surprised for being test data that they didn't flesh it out more over time. Because it really would be fun, because what this chart will allow us to do is really kind of see our you know, how we do year over year. August. Yeah. So now we have all of our months, and we can kind of see our stacked year over year, which again doesn't make much sense in this case. If we wanted to see the same thing, I guess just to like give us a little bit of a different view, we can see so case when month is in 1, 2, 3, then Q1. 4, 5, 6, 4, 5, 6. Then Q2, 8, 9. Three and 10, 11, and 12. And we have our Q4. What did I do here?
Missed then.
Yep, good call. There we go. So anyways, you can, that's kind of like a really nice use case for case statements. I mean, obviously we can use them for a lot of different things, but particularly with our aggregations, it's really nice because we can pull little bits of our data and kind of kick it out so they're columns instead of rows, just kind of like what we've done here. This was a little bit of a roundabout way because technically there's a quarter function that we could have used, but whatever. We did it manually. Okay, any more questions on the case statements? Does anyone have a particular question about them? Does anyone not understand, or would it benefit anyone to have me explain simple versus searched? Okay, I won't cover simple versus searched. It's not super complicated. It's basically just one's really a switch, while the other one's like a really more customizable individual kind of pieces of logic. Cool. Well, we are on a roll. It's only been 30 minutes and I feel like we've covered the topic. Does anyone have any questions about this week's content before I move on? Okay. And the next question I have, does anyone have any questions about final projects or anything else? Because that's really all I had for today. So does anyone have any other questions more broadly related that they'd like answered?
I have a question on my final project, but it's not something that necessarily would help other people.
Got it. Okay. Anyone else? I'll stick around after.
I have a fairly broad question regarding the final projects.
Okay.
As we are working on the CRUD statements for that project, should I can't remember the parameters. Do we need to be writing a CRUD for every table that we've made, or for every like wireframe view as we kind of walk through that mock application?
Good question. And someone just asked this in the teams as well. But and I'm glad you brought that up, because I was actually going to bring it up anyways, because it was just a good question. So basically, there's two deliverables. You have, like you said, you have your CRUD statements, and then you have your test cases. And the reality is they're two separate deliverables, but there may be some overlap. Okay. So what I mean by that is, so your CRUD should be a create, well, your CRUD statement should be an insert, update, select statement, and delete from every table. Basically, you just got to have one of those, and it can be pretty simple. In fact, in the past, I've kind of walked through this where I basically have one of these each. Like, so for system user, I have my create, read, update, and delete. And, and it can just be kind of some fake example data, right? So like in this case, I just delete stuff. And in this case, the CRUD statement, I put it all in a file, so it's easy to submit for the assignment. But in reality, like, I'll probably never necessarily run these. Now, the only exception to that is your insert statements. So because you have to have test data in every table, as a result of your CRUD, really the only statement I would ever run is the insert statement. And I think I've covered this before, where the way I really would go about my project is I would start and I would create a script that specifically just inserts all my test data. So basically just go through in order, because sometimes, there's a hierarchy to your tables depending on how you've set it up. I would go through and just insert all my records. And then from there, now all of a sudden you have every create out of your CRUD for all of your tables. So I would then take and just copy all those create statements into my CRUD file, however you want to organize it, and kind of do it that way. Because that way you immediately have an insert for all of them. So then all you have to do is do a select statement, an update statement, and a delete statement. Now the read statement, what I would do, you could just do select everything from the table, right? That's kind of like the easy way. What I would do is I actually do one of both. And what I do is I pick like the primary search that I would do that's not ID. So like, for example, in this case, where if I'm looking for a system user, I would do it based on the email. If I was doing a recipe, I would do it based on the recipe name and so on and so forth, like whatever kind of like a common lookup kind of parameter is. And the reason for that is because then you can reuse that in a lot of your stuff. So like you can see here, like especially your inserts. So like when you're doing your insert, you can see here that, because I want to make this easy to reinsert my data, rather than, because it's a foreign key, rather than manually type the key, I wrote this little subquery, and this subquery just happens to be the select statement of my table. So, it can become very easy just to kind of like, I guess, repurpose a lot of this lift that you already have to do. So I would kind of mismatch. Okay, here's my insert statement. And you can see that's kind of what I've done here is I started with my CRUDs. I'd write my insert statement, write my select immediately after I insert it, because a lot of times you'll chain these. So like in my case, I was doing a family cookbook. I insert my new users because that's kind of like the most fundamental data. And then I immediately wrote my read statements. And then the next kind of level in my hierarchy is a family. So then I insert into family and I kind of create my family, and the owner user ID is based on the select of my previous table, which was my system user. And then again, I do my select where family is equal to Gamgee house. So this just selects the family I just had. And then if we come down here where I'm inserting into family member, what do you know? I use both these again. So this gets my system user and this gets my latest created family, and so on and so forth. So you can see it becomes very kind of easy to just build on one another. And then it becomes very quickly usable, because then, like I said, you can kind of take your insert statement, plug it over into your script that'll just run all the way through them, and so on and so forth. Does that kind of make sense? So I guess just to play back, I would start, because I think I got this backwards before. I would start with CRUD, and for each table, so this, imagine this loop. For each table, I'm going to write my insert and my read before I move on to the next table, and then I'll copy my insert into a script that will just have all my inserts. Does that make sense?
Yeah, that's very helpful in just organizing like what is needed and how to get all those pieces done. And the hierarchy was kind of my next question, because as I was going through it, I'm like, wait, there's some foundational pieces I had to back up. So that was helpful.
Yep. Yeah. So like if you're looking at your ERD, you'll kind of be able to kind of look at it and say, okay, if everything kind of depends on system user, you kind of have to follow the chain or the funnel all the way to the top, right? It's like the pyramid. You got to try to find the top, and really there could be multiple tops. You know what I mean? It's really branches. You got to make your way to like all the roots of these things, and then kind of pull it in and build from there. So you might have to insert into a few tables before you can insert into this one. Just like in my case, I had to insert a user and a family before I could, put that user in a family, if that makes sense, because you have to kind of have those dependencies first.
Yes. Yeah. Okay. Thank you.
Yep. No problem. And back to the original question on the difference. So really the difference between the CRUD and the test cases. So the CRUD statements are going to be, because like really the seed file that has all your inserts is really for your own utility. And the reason I do that is so like if I ever mess up and I just kind of want to erase and start over, I don't have to start over from scratch and try to manually run, 13 different inserts and make sure they all work. If you script it, you can just delete it and just rerun this whole script, use this little execute everything in the script kind of button and let it just go. And I have a video. One week we kind of went through that whole process where I kind of went through, how to build your schema file, your seed file. And then, the CRUD file is really just an assignment document. I'll never run this one. And I don't think you ever really should, because it's going to just delete everything that you do. So it's kind of like a weird one. It's going to just cause problems. And so the difference between your CRUD statement and your test case is your CRUD is really mimicking an API. And if you've dealt with APIs, you'll know what I'm talking about. REST APIs all kind of have this, where you can post a record, you can get a record, or read a record, you can post updated information, and you can delete a record, all from an API. If you haven't dealt with APIs, the broad overview is that they're very commonly, if you are running a system, the way that your application, so like if I was building a mobile application that relied on a database, you need to have an interface between the mobile application and your database, and that usually transfers over the internet. Naturally, we're very mobile now and rely on the internet. So if you want that kind of interaction to happen, typically you build an API that lets you make calls within your software, HTTPS calls, that will then talk to a web server that will then kind of be the middleman between your information. Let's actually see if I have one here real quick. Wait for it as it pulls up. All right, yeah, so here's some information where basically we can pull from an API. So just yeah.
It's not showing us your screen that you're looking at.
Oh, got it. Let me
it's like ghosted or something.
Yes, let me see. Can you see my Firefox browser?
Nope.
Interesting. It's like it froze. All right. Can you see Visual Studio by chance?
Yes. Yeah, okay. In your desktop.
Now can you see Firefox?
No.
Okay. Well, interesting. Sounds like Zoom is struggling just a little bit. So we'll skip that. But anyways, basically API will let us pull data based on a URL. And you've probably seen this before, like where you can go to a URL, you put the little the question mark, and then you can put parameters behind it and it does different things. Pretty common thing. When you're doing that, what you're really doing is messing with an API. And most APIs just return JSON, especially if you're dealing with like a third-party application. So like I could write an API that says, I want to get all of my system users, for example, if I'm using my kind of system as an example. And it would select all that information. Now, I don't go as crazy to actually say you need to implement like specifically like API type data, but really that's what it's getting at, is it's trying to mimic this thing where, for every table, just as general utility, we want to have a way to get information, insert information, update information, and delete it. And it kind of acts as like is all your tables set up correctly, which is, as far as the assignment is important as well. So the CRUD is really mimicking that. It should never run independently of itself. It's kind of just there as like hey, I went through all the different types of select statements. They all work against my tables. We're all set. That's really what it's there for. Your test case is really going to be more of like, okay, how do I run my UI? So like I said, there may be some overlap. So for example, if I just want to get a list of all the recipes to display, sure, I could just use my select everything from recipe. But odds are most of the time we're going to want to select like the recipe and the author, because we want to display some more information with it. So we'll select the recipe and the author and maybe even some more information. So like if we're doing a store, we might want to select the product seller, the product color options, the product quantity in stock, those kinds of things, which often require joins. So your test case is going to be very much more isolated to, hey, if I load this view and it shows me all of the products available, what do I need to select to kind of show this? Or if I pull my recipe, I want to show the recipe, a photo of the recipe name, and the author of who wrote the recipe, like, in this list. So in that case, I need to write the select statement that's going to pull that data. The ones that are probably a lot more common are your delete statements. Like you probably won't ever have to duplicate those, because really, if I'm viewing all the recipes that I've made and I just want to delete one, and there's a delete button, the delete from recipe where recipe ID equals 1 is probably just going to be in my CRUD statement. And so really, if you build your inserts, your CRUDs, you can kind of leverage a lot of that work inside of your test cases, but ultimately different things. So I would do your CRUD, get that all done, have all your test data in there. And then once you kind of get your UI up there, then you can say, okay, this button, this will do this, or, this view, all this information, it came from this select statement, and so on and so forth. Does that make sense?
Yes.
Okay, perfect. All right. And realistically, if you wanted to, if you really wanted to cut down on work as much as possible, and to me, it kind of just depends on where it lands, you could save your reads, because most of the time you're going to have reads in your test cases, probably more frequently than not. And in that case, you could just take your reads and your test cases and use them as CRUD statements. Because as far as the CRUD statements, I'm not real picky on what exactly they are, as long as it's, for every table you have an insert, select, update, and delete. So I'm not super picky on that. So however you want to go about it, but the way I've kind of outlined it is what I would personally do.
Are there some type of examples of kind of what you're looking for? Like, it sounds like you're looking for multiple files that we're going to be turning in for this.
Yeah. So really what you should have, and I think I have let me see what I have here. Yeah. So basically you're going to have three things, or let me think. You're going to have your ERD, and let me see if I have an example here. I don't think I do necessarily. Yeah, I have this one, and I'm not going to open anything because it's, anyways, it can, and this one may not be the best example, but this is one that I have downloaded at some point. So really you should have kind of, and let me clean this up just a little bit. So I'm just going to move this to trash. Create what we want here real quick. And ultimately I would submit everything you do. So in fact, and I'm going to touch, let's do, so something like this, where basically you need your presentation, which is kind of the last little thing there. And then you need so your presentation, you'll need all your CRUD statements, you'll need all your test cases, you'll need a visual file of your UI map. So whether that's in a PDF, PNG, I don't really care, but your UI map is something viewable. And then your ERD, which can be, again, in like a screenshot. It can be, however you want to do it. So most of you already have your ERD done. Most people are polishing up their CRUDs and test cases, or kind of in the bulk of that. Some people may have already started or finished their UI map. So really, these three files kind of make up the bulk of the work, if we're being honest, especially the test case and the CRUD. The UI map is just there to support the test cases. And then the last little bit is your final presentation PowerPoint. I created this lib folder. So if it were me, I would just throw anything else I do. So for example, like my family cookbook, my my schema file, my seed file, the file that I use to clean things up, I would put all that inside of my lib folder, and submit that as well, because why not? You know what I mean? Does that help? Sorry, I don't have one to really open. I haven't asked anyone for permission yet.
Yeah, that's great. And then how in-depth is the UI map that you have?
So the UI map, so that one I just kind of made, or that's just a plain old file. Let me see. And in one of the videos, I kind of walked through a UI map, and it was right at I think I was just one view short. Let me see if I can find it. I'm pretty sure it's right here. Yes. And can you still not see Firefox, I'm guessing?
It's just a black screen.
Interesting.
Yeah.
Okay. Let me see if I can you see Chrome by chance?
Yeah, we can see that.
Okay, yep. Leave it to Firefox. I try so hard to support the little guy. What do I get? My password. All right. So week 6 announcement really kind of goes through kind of this whole process, but basically I got to the point to where I was just like, one kind of view away. This one's kind of half there away. So this would kind of be what I would submit for my UI map, which is really just like a single process. I've had a lot of people ask, and the truth is a lot of it just depends on what you're building. So what I did for my recipe is what I like to see is like the single process. So in this case, I create my recipe, and then once I create my recipe, then I have this place, and this is kind of like the main screen. So like you select your cookbook, you put your name in of your recipe, how many estimated minutes it takes, a little description, you hit save. And at this point, it would take you to here, where is really functions as both an update and a kind of a manage your recipe. So this is where you manage your new recipe. So in this case, I can add steps to my recipe, delete steps from my recipe, and so on and so forth. And then the one that's missing that I just didn't have time to finish is where I actually build each one of my steps. So like if I click add step, it would take you to this screen where, I put in all the step information. When I hit save, it would actually go back to this one just with the step added, so on and so forth. So a little bit of jumping back and forth, but you kind of get the picture. And then this last view is just a view of the recipes. So if I'm browsing and I want to look at everyone else's recipe, this is kind of that view that also isn't quite polished off, but you can kind of get the gist of it. Does that make sense?
Yes, thank you.
Yep. And like I said, this video kind of goes in depth on as far as I think that's the one where I really kind of go through the whole process of starting to kind of build out the CRUD and test cases and stuff like that. So that one may be helpful.
Where did you make the that UI? Sorry.
Yeah, so there's this really cool thing, and there's a paid version, but if you Google Excalidraw, there's this draw dot. So it's not the first one because this one costs money, but there's this draw.myu.io, and it is really cool. So you can actually see here, it's saved my stuff, which is cool. But it's really nice because you can just kind of draw boxes. So people like me who are very, very not talented in the kind of artistic area, I can just very quickly draw boxes. So like in this case, if I wanted to, kind of flesh out my step editor, I can kind of go through here and had a little hiccup for a minute, just kind of draw your boxes. And it's actually pretty dang nice for wireframing. So I highly recommend it. It's free, super easy to use, super intuitive. You can kind of pre-build objects or shapes. So like, for example, if I wanted to build like this, if I kind of wanted to build like a UI element that's going to repeat over and over, like in this case, I need ingredients. So like, I'm just going to build, well, in fact, like my little trash can here. Let me select my little trash can, and I'm just going to copy this and let's paste it over here. I can actually just save this as a thing. So I'm going to group this, and then I'm going to add to library. And so now I can go to my library and I have this, and it looks like I've already it's because it's selected. So now I have my little trash can as an item. So now instead of having to recreate my trash can, a million times, I can just kind of plug it in there. Additionally, if I wanted to, so like I could say, row title. And in this case, I'm going to kind of go about it a little different. So instead of row title, I'm going to call this ingredient. If you wanted, you could make it way more uniform. And quantity. So now if I wanted to kind of save my whole row, same thing. I'm just going to group it and add to my library. So now instead of having to, do it tons and tons of times manually, I can just kind of go put it in there. So anyways, shout out to Excalidraw, or they call it Excalidraw up here. I don't know what where the name comes from, because there's a paid one and this one that's free. So I'm not sure. I call it Excalidraw, even though it's really not, but it works great.
Thank you.
Yeah. All right. Any other questions? All right. Sounds like we're all set. So if anything comes up this week, feel free to let me know. Otherwise, good luck. We are getting kind of closer to the end. We're in week 10 right now. I'm about halfway through week 10. So you've got about 3 more weeks for final projects before you really want to start kind of like sweating a little bit more. So it, depending on where you're at, you may have to work faster. Maybe you're on task. I'm not sure. But if you get stuck, because we're getting close to the end, if for whatever reason you're stuck, feel free just to shoot me a note on Teams. More than happy to help. Most times I can kind of help get you plugging away on a little bit faster than if you try to brute force it. So if you're stuck, just let me know. More than happy to jump in there and help you. But otherwise, good luck this week.
Thank you.
Yep. Thank you.
Thank you.
Thank you.
Thank you.
Yes. Thank you.